Hello everyone, welcome to my YouTube channel, Understanding Voice Gateways. I am Ritesh Mishra. I am a Cisco voice engineer working on voice technology for last 6 years. I have experience of TAC as well. So today we are going to talk about PRI, Primary Rate Interface. So PRI is a TDM technology that we use to connect to the provider, and it can be used for voice, video, and data purpose. So a single PRI connection can be used to handle multiple channels, multiple calls, voice, video, data channels. Unlike FXO, where you can have only one call per cable or per port, but a PRI can have multiple calls. So PRI is a digital telecommunication connection that allows 23 or 30, depending on the type of PRI that you are using, uh, of the voice video data traffic between the network and the user. So it's a physical piece of equipment. Actually, it's also called a PRI line or circuit, sometimes referred to as a circuit as well. So if you see the history of PRI, PRI has been around since 1980s. It uses a pair of copper cables, and there are two types of PRIs. Basically, it's T1 and E1. We'll be seeing the difference between these two PRIs the next slides. So here we will be discussing about the basics of PRI, troubleshooting of the PRI, the basic troubleshooting, L1, ISDN layer 1 and ISDN layer 2 troubleshooting. We'll also see the debug of the PRIs and how to collect the debugs, what debug commands can be used, and how to analyze the debug using a Notepad++ file in the next video. In this video, we'll be covering only the basics of PRI and how to debug, how to troubleshoot layer 1 and layer 2 issues of PRI. And we will be discussing PRI only on the base in perspective of the voice uh, signaling, voice troubleshooting, not data or video. So there are two types of PRI basically. It's E1 and T1. So the major difference is the geographical difference. E1 is used in Europe, Asia, and Australia. Uh, T1 is used in United States, Canada, and Japan. Uh, E1 have 32 um, channels in total, out of which 30 can be used for voice video data. One channel is for signaling, other channel is for clocking and synchronization. In T1, there are a total of 24 channels, out of which 23 can be used for voice, video, and data. One is for signaling. Each of these channels has a capacity of 64 kbps. E1 has total transmit and receive rate of 2.048 Mbps and T1 has 1.544 Mbps. So this is T1 and E1. If you are in India or Southeast Asian countries, you will be using E1 PRI. If you are in United States, Canada, or Japan, you will be using T1 as a PRI. So when you have a ISDN card plugged into the router, so you have to inform your router whether you are going to use this ISDN card as a T1 or E1 card using a voice card command, right? So, and after that, the configurations will follow. So this is the basics of PRI. We'll also see how to troubleshoot layer 1 and layer 2 of the PRI, okay? So let's start the layer 1 troubleshooting. So the major command that we use to troubleshoot or check the status of PRI in a Cisco voice router is a show controller T1 or E1 and show ISDN status. The show controller T1 and E1 shows whether your PRI is up or down, the particular circuit is up or down, what type of line code and framing you are using, whether you have some slip errors and errors on the line. So this command can be used to get the status, the physical status. Show ISDN status shows the output of a layer 1 status, layer 2 status, and layer 3, everything. So we'll see what are the good states and bad states of ISDN layer 1 and layer 2. So If you run this command show controller T1 or E1, this will be the output you will be seeing. You might see that T1 1 by 0, which is the circuit ID of that particular PRI port and port number of that particular PRI is down or up. If it's down, that can be a physical problem. You might have a cabling issue, card is faulty. There might be a problem from the provider side, but go to the provider only after you are sure of your physical connectivity, the cables and the ISDN card. So this command shows the physical status. Show ISDN status shows you the layer 1 and layer 2 status. So if you see the good states of layer 1 is active, good state of layer 1 is active, bad states are deactive and shut down. Good state of layer 2, ISDN layer 2 is multiple frame established, and bad state is tie assigned and awaiting establishment. If you see the layer 1 to be shut down, that means it can be an administrative shutdown issue. So try to unshut and shut your PRI controller. If it's not happening, it's not coming to active state, try to check the cable and the card, and then reach out to the provider. If it shows as active, but your layer 2 is in tie assigned or awaiting establishment state, or maybe flapping between tie assigned and awaiting establishment, and in that case, you have to collect layer 2 debugs to check whether we are receiving a response or not. We'll see what layer 2 debugs are, what is the command and what outputs can be seen, and what are the expected outputs in layer 2 debugs. So for now, understand that whenever you connect to PRI, it first goes to active state in layer 1, and then layer 2 states changes and transitions between tie assigned to awaiting establishment to multiple frame established. So as soon as you plug in the PRI cable, the layer 2 state will first show you tie assigned, then it will try to make a connectivity connection with the ISDN switch and changes its states to awaiting establishment. Once the connection is established, it changes its states to multiple frame established. So this is how the transition happens. Now, during this transition, we'll be able to see what debugs or what outputs can be seen in the layer 2 debug ISDN Q921. So those messages are very important, and that will help you to isolate whether the problem is on your Cisco router or is it from the provider side, because sometimes your layer 2 shows tie assigned and awaiting establishment. You go to the provider and provider says there are no issues from their side. In that case, you have to provide a proof to the provider that, see, this is the problem, this output is expected, but we are not receiving. We'll see what output is expected. So remember these two commands, show controller T1 or E1 and show ISDN status. These are the famous command and most widely used for troubleshooting ISDN or PRIs. Okay. So if we revise, we have the PRI is a end-to-end digital telecommunication circuit. It can be used to have multiple sessions in one PRI connection. So there are two types of PRI, E1 and T1. E1 is for Europe, Asia, and Australia. T1 is for United States, Canada, and Japan. The difference is the number of channels. E1 has 32 channels, but only 30 channels can be used for voice video data. T1 has 24 channels, but only 23 channels can be used for voice video data. And remember these two commands, show controller T1, where you will be seeing whether your PRI is up or down, and show ISDN status, where you will be able to see the status of ISDN layer 1 and ISDN layer 2. Good state of ISDN layer 1 is active, and good state for ISDN layer 2 is multiple frame established. Now, so to troubleshoot the layer 2, suppose your layer 1 is active, but layer 2 shows that it's tie assigned or maybe awaiting establishment, or maybe it's toggling between tie assigned and awaiting establishment. Then you have to collect debug ISDN Q921 in the router, and you have to check the logs. So what is expected is, so how it happens is, when you connect the PRI after layer 1 becomes active and layer 2 still shows tie assigned, your PRI connected to the Cisco router and the ISDN switch towards the provider starts exchanging this message. So either party, the SubMIP message can be sent by the either party. It can be sent by the provider side or by the Cisco router side. But suppose example, our router initiates this SubMIP message. Okay, so when I say initiates, it's very easy to see in the logs who is sending this SubMIP message. So here in our case, if you see, we have TX, that means transmit. So this logs are taken on the Cisco router. So TX means our router is transmitting this message towards provider because this connectivity is between Cisco router and the provider. So if we are sending a message, that means we are sending it to the provider. If we are receiving a message, that means we are receiving it from the provider. So this is how it starts. As soon as you connect it, the layer 2 starts with this message. Either party will send this SubMIP message and the other party has to respond with this unnumbered acknowledged frame UAF. So in this message, this one, our router is sending this SubMIP message and provider is responding. We are receiving, if you see this RX, we are receiving this UAF message from the provider. That means it has, the other party has responded, and after that, the PRI will change its state to multiple frame established. But what if it's not changing the state? In that case, you might be seeing that our router is sending this SubMIP message, but the provider is not responding with a UAF message or maybe responding with a bad frame. In that case, you can collect the logs, show it to the provider that, see, we are sending a SubMIP message, but you are not responding with a UAF, or maybe you are responding with a bad frame. This is not expected message. We should receive a UAF when we send a SubMIP. It can be other way around as well. If provider is sending a SubMIP, the router should respond with UAF message. If it's not responding, check your ISDN card. In that case, you have to do a hardware loopback test or software loopback test of the ISDN card. I'll put a link in the video on how to do the software loopback test or hardware loopback test of the PRI. That shows the health of the ISDN card. That test is to check the health of the ISDN card. And if the test fails, you might have to replace the ISDN card. So this is the expected messages that you should be seeing in ISDN Q921, debug ISDN Q921. So one party should send SubMIP, other should respond with a UAF. After this successful exchange of messages, what happens? As soon as the successful exchange of SubMIP and UAF happens, your PRI will change its state to multiple frame established. And once the PRI is multiple frame established, it will start the exchange of these messages, RRP and RRF, and it happens every 10 seconds. So if we are receiving RRP, see the RX, it's very easy to understand who is receiving and who is sending the message. RX plus the arrow, the incoming arrow, and this is an outgoing arrow. Okay, so RX, we are receiving RRP, router should respond or transmit TX RRF message, and this happens every 10 seconds if you see. Okay, now how a PRI comes to know that connection is the connection with the provider is lost. So it happens because this RRP RRF are kind of keep alive messages. So once there are 4 consecutive misses in the keep alive, that means after 40 seconds, if any of the party failed to respond to this keep alive messages 4 times, the PRI state will change from multiple frame established to tie assigned again, and it will again try to establish the connection. So again, those SubMIP and UAF messages will start. Once it has a successful exchange of those messages, the PRI will change its states to multiple frame established. And again, this keep alive will start at the interval of 10 seconds each. So RRP and RRF at the interval of 10 seconds each. And 4 consecutive misses changes the state of PRI from multiple frame established to tie assigned. And again, that we learned in the previous slide, it will start the exchange of these messages again. So this is how a PRI changes its states from tie assigned to awaiting establishment to multiple frame established. So let me show you those output commands in my lab router quickly. So I have a PRI configured here, but I don't have a connectivity. So you might be seeing everything as down. So show controller, I have an E1 configured here. If you see, its E1 is down. You'll be also able to see the framing being used, line code that is being used. So remember, HDB3 is a line code for E1. AMI is line code for T1 lines, T1 circuits. So even one by one is down. So this is the show controller E1 output. You will be able to see show ISDN status. And if your PRI is up, it will show you multiple frames established. If not, it will show you tie assigned. Even here in layer 1, it shows as shutdown, which is a bad state. So it can be an admin shutdown, or maybe the PRI itself is not active. It's not active from the provider side. So this is the output that you will be seeing. It shows out which port the states layer 1 or layer 2 output belongs to which port or which circuits. It 1 by 0. 15, why it's showing 15 is the 15 is the signaling channel for E1 lines. If it would have been a T1 line, you will be seeing a 23 colon 23 here. So 15 is the signaling channel. Actually, it's the 16th channel, but in Cisco router, the channel starts with 0. So it's the 16th channel in E1, which is the signaling channel. Since it's starting from 0, it shows 15 as a number here, the 15th channel. So this is the signaling channel. Actually, it is the 16th channel because it starts from 0. So this is how you troubleshoot PRI layer 1 and layer 2. In the next, and if you and the debug ISDN Q921 has to be run on in the privilege mode. This is the simple command debug ISDN Q921, and when you do a show log, you'll be seeing these outputs. So you might not be seeing the output here because I don't have an active PRI, but this is the command that you have to run, debug ISDN Q921, and just do a show log. You will be seeing the exchange of messages. If it's not exchanging, go out to the provider saying that your provider is not responding with the UAF. So there might be some problem at the provider side. So this is how you troubleshoot a PRI. In the next video, consecutive video for this PRIs, I'll be showing you guys how to analyze the ISDN Q931 debug in a Notepad++ file. What are the important things that has to be marked in a raw debug file? And before that, we'll also be seeing the call flow of PRI, which is very important when you are reading or trying to analyze the debug of any of the protocols or TDM connectivity. So the call flow is very important. So we'll be seeing the call flow first in the next video, and I'll show you what debug command can be used and how to analyze that particular debug. Till then, everyone stay safe, stay home. Please subscribe to my YouTube channel. Comment if you want me to go through any of the topics related to voice gateways, and share this video and like the video. Till then, have a great day, guys. Bye bye. Take care.